Molecular formulas are generally introduced to chemistry students as the number of atoms of an element in a molecule. This is true, but chemists generally report amounts of substances in terms of moles. Another way to define the molecular formula is the exact number of moles of elements per mole of compound. Methane, for example, has 1 mole of carbon and 4 moles of hydrogen per mole of methane. Ethene has 2 moles of carbon and 4 moles of hydrogen per mole of ethene, while benzene has 6 moles of carbon and 6 moles of hydrogen per mole of benzene. Note the definition of the empirical formula. It is the simplest whole number ratio of moles of element in a compound. In other words, how do the moles of elements in a compound compare? In methane, there is 1 mole of carbon per 4 moles of hydrogen. The empirical formula is CH4. Yes, the molecular formula and the empirical formula can be the same. But look at ethene, C2H4. The ratio of 2 carbons to 4 hydrogens can be simplified to 1 mole of carbon for every 2 moles of hydrogen. The empirical formula is CH2. And for benzene, the carbon-hydrogen ratio of 6:6 can be simplified to 1:1, and the empirical formula is CH. Because the empirical formula is the simplest whole number ratio of elements in the molecular formula, the molecular formula will always be some whole number multiple of the empirical formula, represented here by the letter N. The ratio N represents the molar mass of the molecular formula divided by the molar mass of the empirical formula. The molar mass of the molecular formula must be given in the problem. Here is an example. The empirical formula for a compound is CH. That is, there is 1 mole of carbon per mole of hydrogen present in the compound. The molecular formula is 104.16 grams per mole. Find the molecular formula. The molecular formula is equal to the empirical formula times the ratio of 104.16 over 13.02. The molar mass of the molecular formula is given to us in the problem, and the molar mass of the empirical formula is 13.02. This is because it comes from 1 mole of carbon and 1 mole of hydrogen, which are 12.01 and 1.01 grams per mole respectively. This ratio is equal to 8. We can distribute the 8 equally to each element and find the molecular formula, C8H8.